What would you expect to happen if a nuclear bomb exploded in space? This isn't a hypothetical question from a science fiction novel, but a very real experiment conducted at the height of the Cold War. The year was 1962. The Soviet Union had just resumed nuclear testing, sending a wave of anxiety throughout the Western world. The United States, in a bid to understand the potential consequences of nuclear warfare in space, devised a high-altitude nuclear test, part of Operation Fishbowl and the larger Operation Dominic. This test, named Starfish Prime, stands out in the annals of history for its audacity and its unforeseen consequences. The plan was ambitious. A Thor rocket, packed with a W-49 thermonuclear warhead and a Mach 2 re-entry vehicle, was to be launched from Johnston Atoll, a small island in the Pacific not far from Hawaii. This wasn't just a demonstration of military prowess, but a scientific endeavor aimed at understanding how nuclear explosions would interact with Earth's upper atmosphere and magnetic field. But the journey to Starfish Prime was not without its share of hurdles. An initial attempt, codenamed Bluegill, was lost and subsequently destroyed due to a radar tracking failure. Undeterred, the team pressed on, only to face another setback when a second attempt under the Starfish designation was aborted mid-flight due to a failure in the Thor launch vehicle. The stakes were high. The eyes of scientists, military personnel, and government officials were all trained on this precarious project. The world waited with bated breath as the team made the final preparations for the third attempt. And then, on the fateful night of July 9th, under the vast expanse of the Pacific sky, the Thor rocket finally took off, carrying with it not just a thermonuclear warhead, but the hopes and fears of a world caught in the throes of the Cold War. Despite several setbacks, the stage was set for a spectacular, yet unnerving display of nuclear power. The countdown to Starfish Prime had begun, and the world was about to witness an event that would forever change our understanding of space, nuclear warfare, and their intersection. As the clock struck 11 p.m., the Thor rocket successfully delivered its payload into the Earth's upper atmosphere. The air was thick with anticipation as the 49 thermonuclear warhead entered the vast expanse of space, settling at an altitude of 250 miles above the Pacific Ocean. And then, in an instant, an explosion of monumental proportions shook the quiet night sky. The detonation of the warhead was nothing short of a spectacle. It was as if a new star had burst into existence, casting an ethereal glow across the ocean's surface. The night sky was transformed into a canvas of vibrant colors, a mesmerizing light show that could be seen as far as 900 miles away in Hawaii. But this beautiful display belied the raw power of the explosion and the chain of events it would set in motion. The immediate aftermath of the explosion was marked by an intense electromagnetic pulse, or EMP. This was not just any pulse, but one that far exceeded any predictions. It was a brief but potent burst of electromagnetic energy, the likes of which had never been seen before. This EMP swept across a vast area, reaching as far as Hawaii, where it left a trail of electrical disturbances in its wake. Streetlights, numbering around 300, blinked out, plunging parts of Hawaii into darkness. Alarm systems, caught in the EMP's grasp, were triggered, causing a wave of confusion and concern. A key microwave link, operated by a telephone company, was damaged, disrupting communications across the island. The EMP was a force of nature, unpredictable and uncontrollable, and it was just the first sign of the impact Starfish Prime would have. As the dust settled and the initial shock of the explosion subsided, it became clear that the Starfish Prime test was more than just a demonstration of nuclear capabilities. It was a turning point, a moment that would change our understanding of space and the effects of nuclear explosions. Little did anyone know, the most significant consequences were still to come. In the aftermath of the explosion, Hawaii experienced a strange, artificial aurora. The Starfish Prime detonation had immediate and unexpected effects on Earth. The explosion generated an intense electromagnetic pulse, or EMP, which was far stronger than any scientist had anticipated. This EMP caused electrical disturbances on a scale previously unseen. In Hawaii, located nearly 900 miles away from the detonation point, these disturbances were particularly noticeable. Suddenly, about 300 streetlights flickered out, plunging parts of the Paradise Archipelago into darkness. Burglar alarms, confused by the electromagnetic disruption, started blaring out of sync, sending waves of unease throughout the quiet night. Even the telephone company wasn't spared. Their microwave link was damaged, leading to a significant disruption in communication services across the island. But the light show in the sky and the chaos on the ground were just the beginning. The Starfish Prime test had more far-reaching consequences than anyone could have predicted. The nuclear explosion had created artificial radiation belts around our planet, trapping energetic electrons within Earth's magnetic field. This was a phenomenon that had not been anticipated, and its effects were significant. These radiation belts, invisible to the naked eye but very much present, began to interfere with the satellites orbiting the Earth. The first commercial relay communication satellite, Telstar, started to malfunction. Ariel 1, the United Kingdom's first satellite, also began to show signs of distress. Both satellites eventually failed, their demise hastened by the high levels of radiation they were suddenly exposed to. The Starfish Prime test had turned the space around Earth into a hostile environment, even for the machines designed to function there. It was a stark reminder of the power and unpredictability of nuclear explosions. But the effects of Starfish Prime were not limited to Earth. The repercussions were felt beyond our atmosphere, in the vast expanse of space that surrounds our blue planet. And these effects would have significant implications for our understanding of space, our technology, and our future explorations. Beyond our planet, the echoes of Starfish Prime were just beginning to be felt. The detonation of Starfish Prime caused an unexpected and dramatic impact on space. The immediate electromagnetic pulse was just the beginning. The explosion had a far-reaching consequence that no one had anticipated. It created artificial radiation belts around Earth, essentially trapping energetic electrons within the planet's magnetic field. These artificially induced belts of radiation had a profound effect on several satellites orbiting Earth at the time. Among them were the first commercial relay communications satellite, Telstar, and the United Kingdom's first satellite, Ariel 1. These satellites were designed to withstand the naturally occurring radiation in space, but the levels of radiation produced by Starfish Prime were far beyond what they were built to endure. Telstar, the pioneer of satellite television broadcasting, was launched just 2 days after the Starfish Prime test. Its mission was to relay television signals, telephone calls, and fax images between America and Europe. However, the excessive radiation caused severe malfunctions in Telstar's transistors, leading to its eventual failure. Ariel 1, the UK's first satellite, met a similar fate. Launched in April 1962, it was designed for ionospheric research. The unexpected radiation levels from Starfish Prime significantly reduced Ariel 1's efficiency and lifespan. By late 1962, it was effectively dead, a casualty of a man-made radiation belt. The long-term effects of Starfish Prime stretched far beyond these immediate satellite failures. The test underscored the vulnerability of our expanding space-based infrastructure to nuclear explosions and the resulting electromagnetic pulses. As we began to rely more and more on satellites for communication, navigation, and research, this newfound vulnerability posed a significant threat. The lessons learned from Starfish Prime continue to shape our approach to space exploration and technology. We've come to understand that actions taken here on Earth can have far-reaching effects beyond our atmosphere, impacting our technological assets in space. Starfish Prime had revealed a new vulnerability in our increasingly connected world. The test served as a stark reminder of the potential dangers posed by human activities in space and of the importance of responsibly managing our activities beyond our planet. Starfish Prime was more than an experiment. It was a lesson. This extraordinary event of 1962 holds crucial insights that extend far beyond the Cold War era, reaching into the present day and the future of our space endeavors. One of the most significant revelations was the vulnerability of electronics and satellites to electromagnetic pulses, or EMPs. The intense EMP from Starfish Prime's detonation led to widespread electrical disturbances and caused several satellites to malfunction and fail. This unexpected outcome brought to light a new dimension of space vulnerability, one that scientists and engineers continue to grapple with in today's technologically advanced world. In the aftermath of Starfish Prime, the scientific community realized the importance of understanding and mitigating the impacts of EMPs. The test underscored the need to design and build more robust electronics and satellite systems that could withstand such extreme conditions. This knowledge has proven invaluable in our current age of space exploration, where satellites play a crucial role in everything from weather forecasting and GPS navigation to telecommunications and scientific research. But the lessons of Starfish Prime extend beyond the technical realm. They also highlight the ethical and environmental implications of our activities in space. The creation of artificial radiation belts around Earth was an unforeseen consequence of the test, a stark reminder of the potential for human activities to impact environments far removed from our own. As we continue to reach out into the cosmos, these lessons underscore the need for responsible space practices, ensuring that our exploration and utilization of space does not harm the very environments we seek to understand. In the end, Starfish Prime served as a wake-up call. It demonstrated the sheer power of nuclear technology, the potential dangers of its misuse, and the far-reaching effects of our actions. Today, as we stand on the cusp of a new era of space exploration, the lessons of Starfish Prime are more relevant than ever. As we continue to reach for the stars, the story of Starfish Prime serves as a stark reminder of our actions' far-reaching consequences.